Good morning, good afternoon, or good evening, depending on where you are in the world. I would like to present to you three articles of interest. And before I do, I would like to let you know this is for review, informational, and educational purposes. It's not to take the credit for the intellectual property of the article. The full credit of the intellectual property of the article goes to the publisher, which is phys.org, and the story by ScienceX staff. Headline reads, New technique achieves visualization of instantaneous states of materials in high-speed devices. Now here we see an example of what they're referring to as referring to a device. And also we have, I believe, what is this? Theta equals minus 50 PS. And the caption reads, credit goes to ACS Photronic 2024 DOI 10.1021 slash AC Photonics. Looks like dot 3, it's kind of small here. Oh, sorry, ACS Photonics dot 3C01532. Copyright provided by phys.org. Let me bring it down to the regular level. And now the article itself. Researchers at the University of Tsukuba have developed an ultra-fast time-resolved scanning electron microscopy instrument by integrating a scanning electron microscope with a femtosecond laser. The innovative system facilitates the observation of the instantaneous states of various materials. Their paper is published in the journal ACS Photonics. The rapid advancement of electronic devices, which underpins modern society, demands increasingly faster operating speeds. Active research and development efforts are directed towards the next generation of technologies that surpass today's fastest 5G band, known as beyond 5G. To facilitate development of these ultra-fast semiconductor devices, precise measurement of high-speed phenomena, such as electric potential and electron transfer within devices, is crucial for understanding their operation. To tackle this challenge, a research group combined a scanning electron microscope with a femtosecond, which is 10 to the negative 15 second laser, measure potential changes in device materials with high temporal resolution. They use the instrument for performing scanning electron microscopy, or SEM, which is capital SEM, of a photoconductive antenna device on capital G, lowercase a, capital A, lowercase s substrate, and obtain capital SEM images with a resolution of 43 picoseconds. Now, by the way, the uppercase and the lowercase have a significance in physics because, for example, uppercase E is different than lowercase e in terms of what it stands for. Anyway, let's continue. So the article ends by saying these findings enable the measurement of our electrical circuit performance across the bandwidth of 23 gigahertz, which exceeds a frequency typically used in 5G communications. This breakthrough technology offers non-contact high-speed three-dimensional measurement of dynamic potential changes at arbitrary points within device structures. It is anticipated to be a vital tool in the development of next-generation electronic devices. For more information, Yusuke Arashida et al. Visualizing the transient response of local potentials on photoconductive antennas using scanning ultra-fast electron microscopy, ACS Photonics 2024, that's DOI 10.1021 slash ACS Photonics .3C01532, provided by the University of Tsukuba. The publisher would like to let you know that the story was originally published on phys.org. Subscribe to their newsletter for the latest high-tech news updates. All right. Very interesting. Now, let's go on to our second article here. Before I read this second article, I would like to let you know that this is for review, informational, and educational purposes. It's not to take the credit for the intellectual property. The full credit to the intellectual property of the article goes to the publisher, which in this case is BBC, and the story by Michael Dempsey, looks like. Technology reporter. Headline reads, could the flying piano, and he has it in single quotes, flying piano, help transform air cargo? And in front of us, we have a picture of this. It looks like something from the 1930s or something. Looks like one or two, say like a single, like one or two engine aircraft with some really long wing or something on top of it. So the caption reads, dubbed the flying piano. Aerolane's 10th aircraft is surfing air currents. Copyright Aerolane. U.S. startup Aerolane is seeking the secret to airborne surfing. Geese already know how to do it. When you see them flying in the V formation, they are surfing on air currents created by formation members ahead and around them. At an airfield in Texas, Todd Greats is hoping to use that concept to disrupt the market for air cargo. Airplane has been mimicking the tricks used by migrating birds, aided by modified planes towed into the air by another aircraft. Smoke released from the landing plane allowed cameras installed on the towed aircraft to capture vortices in the air that a glider can exploit by stay aloft. Their latest test aircraft is known as the Flying Piano because its poor gliding characteristics. Its twin engines idle for electrical power while it glides along with propellers turning for purely aerodynamic purposes. Other tests have measured the tension of the towing line. They spotted when the line went slack, indicating the glider is surfing along on current generated by the aircraft ahead. Arrow's plan is to feed all of the data into a program that will guide an unmanned cargo plane through the wakes and turbulence to exploit the possibilities of gliding long distances without burning fuel. Which I've thought of that. I wondered if aircraft could do that, but apparently they can. So, and I've heard on the passenger planes, they have some sort of way that they can glide for X amount of miles, even when the engine is down. Anyway, one or more such cargo planes could be towed by a jet, also carrying cargo to their destination where they could land autonomously. The only fuel cost would come from supplying the towing aircraft's engines. In theory, this should work like a truck pulling a trailer with air currents doing much of the heavy lifting. This is what Mr. Greats calls a combination of gliding and surfing. The same idea occurred with Airbus, which tested the technique in 2021 with two A350 airliners flying 3 kilometers, which is 1.9 miles apart across the Atlantic. Although the aircraft were not connected to the tow line, the experiment saw one aircraft winning an uplift from the lead A350's wake to reduce CO2 emissions and fuel burn. And here we see a picture of just that. And the caption reads, Airbus has experimented with flying a jet in the wake of another to conserve fuel. Copyright Airbus. Mr. Greats, a pilot with 12 years experience, founded Aerolane with Gur Kimchi, a veteran of Amazon's drone delivery project, on the basis that, quote, there has to be a better way to get more out of the existing aircraft, unquote. Now, the project has raised eyebrows among experienced pilots. Flying large gliders in commercial airspace means meeting strict flight safety regulations. For instance, the towing aircraft has to be confident it can release the tow line at any point in the flight, safe in the knowledge that the autopiloted glider can make it down to a runway without dropping on top of the local population. Well, yes, of course. Aerolane says the small electric motor driving a propeller will act as a safety net on their cargo gliders. giving them enough juice to go around it again if a landing looks wrong or to divert another location close by. And here we see a picture of that. See the long wings? The caption reads, "Airliner hopes that the gliders, something like this, may one day carry air freight. Copyright airline." Well, I hope you don't lose it. So, and I hope it's insured. That's all I can say. Make sure it works. At least, yeah, I'm gonna say at least reliably. Mr. Greats counters that Aerolane employs active commercial pilots who are hard-headed about the practicalities of the project. Quote, "We've engaged outside advisors to be devil's advocate," he adds. He says big freight businesses are interested in anything that allows them to cut the cost per delivery. On top of the cost of fuel, air freight firms also have to think about jet engine emissions and shortage of pilots. James Earle, a former RAF helicopter pilot and aviation consultant, thinks Mr. Greats may just be onto something. And by the way, that stands for Royal Air Force, I believe. Or Royal Australian, or Royal Air Force. Quote, "It stands to reason that that gains can be had by slipstreaming and combining efforts in the sky, and any innovation in the cargo space is good. However, he cautions the public acceptance of unpowered cargo flights over built-up areas is another thing entirely. Quote, "It should have been a gliding range to get a landing spot in the event of a major failure by the tow plane. Whether this can be effectively communicated to the public is another matter, though." And in front of us, we have a picture of this plane and presumably the pilot looks like. Fred Lopez was initially skeptical about aeroplanes' prospects. Copyright Fred Lopez. Apparently, this is his photo. Regulators are also likely to be cautious as well, particularly in the U.S., where the Federal Aviation Authority is under pressure after serious problems with Boeing aircraft. Mr. Greats replies that his team has complied with every request from the FAA so far. Quote, "The FAA has always been super risk averse. That's their business," unquote. Fred Lopez spent 36 years in the aviation operations at cargo giant UPS. As he says, he's put, quote, "my entire adult life," unquote, into working out the most cost-effective way to operate an air freight business. Mr. Lopez admits he was profoundly skeptical about air cargo gliders when Aerolane, Aerolane first approached him. But the prospect of serious fuel savings won him over, and now he sits on the advisory board. Cutting fuel costs is an obsession of civil aviation. When the upturned wing tips we see out of the cabin window became a standard design feature, airlines cut fuel costs by around 5%. But gliders only consume the fuel required by their tow plane. If that too is a cargo aircraft, a pair of gliders drawn by one jet represents a significant reduction in fuel consumption on a large shipment. The initial Aerolane design uses their autopilot plus what Mr. Lopez terms as a human, quote, "safety pilot," unquote. This should make certification from the FAA easier. Quote, "Aerolane is not trying to change anything at one go," unquote, he says. Their ultimate goal is an autonomous operation using AI, as Mr. Lopez puts it, quote, "to pull the pilot out of the seat," unquote. And if the flying piano can surf, then who knows what's possible. Very interesting idea. I wasn't expecting they would term it as a flying piano. Okay. Interesting. Not how I would say it, but that's how the author put it. So that's what it is. Let's talk about our third and final article here as we switch gears over to another type of technology. And before I do that, I would like to let you know this is for review, informational, and educational purposes. It's not to take the credit for the intellectual property of the article. The full credit to the intellectual property of the article goes to the publisher, which in this case is The Conversation, and the story by Bashi Chong, postdoctoral researcher in quantitative biosciences, Georgia Institute of Technology. The headline reads, Mobile robots get a leg up from a more is better communications principle. And ahead of you, you see the picture of this mobile robot. The caption reads, Getting a leg up from mobile robots comes down from getting a bunch of legs. Copyright Georgia Institute of Technology. Now to the article itself. Adding legs to robots that have minimal awareness of the environment around them can help robots operate more efficiently in difficult terrain, my colleagues and I found. We were inspired by the mathematician and engineer Claude Shannon's communication theory about how to transmit signals over distance. Instead of spending a huge amount of money to build the perfect wire, Shannon Shannon illustrated that it is good enough to use redundancy to reliably convey information over noisy communication channels. We wondered if we could do this with the same thing for transporting cargo via robots. That is, if we want to transport cargo over, quote, noisy, we have this in quotes, noisy terrain, say fallen trees and large rocks, in a reasonable amount of time, could we do it by just adding legs to the robot carrying the cargo and do so without the sensors and cameras on the robot? Most mobile robots use inertial sensors to gain an awareness of how they are moving through space. Our key idea is to forget about inertia and replace it with the simple function of repeatedly making steps. In doing so, our theoretical analysis confirms our hypothesis of reliable and predictable robot locomotion, and hence cargo transport, without additional sensing and control. To verify our hypothesis, we built robots inspired by centipedes. We discovered that the more legs we added, the better the robot could move across uneven surfaces, without any additional sensing or control technology. Specifically, we conducted a series of experiments where we built terrain to mimic an inconsistent natural environment. We evaluated the robot locomotion performance by gradually increasing the number of legs in increments of 2, beginning with 6 legs and eventually reaching a total of 16 legs. And here we see a related video. It says centipedes inspired many-legged robots that traverse and was cut off. I take it that's difficult terrain or difficult something. That video will be available upon publishing of this article, as it is an embedded link in this article that you can see in front of you. Now, as the number of legs increased, we observed that the robots exhibited enhanced agility in traversing the terrain, even in the absence of sensors. To further assess its capabilities, we conducted outdoor tests on real terrain to evaluate its performance in more realistic conditions, where it performed just as well. There is potential to use many-legged robots for agriculture, space exploration, and search and rescue. Why it matters? Transporting things, food, fuel, building materials, and medical supplies is essential to modern societies, and effective goods exchange is the cornerstone of commercial activity. For centuries, transporting material on land has required building roads and tracks. However, roads and tracks are not available everywhere. Places such as hilly countryside have limited access to cargo. Robots might be a way to transport payloads in these regions. I can say might be a way, but yes. What other research is being done in the field? Other researchers have been developing humanoid robots and robot dogs, which have become increasingly agile in recent years. These robots rely on accurate sensors to know where they are and what is in front of them, and make decisions on how to navigate. However, their strong dependence on environmental awareness limits them in unpredictable environments. For example, in search and rescue tasks, sensors can be damaged and environments can change. What's next? My colleagues and I have taken valuable insights from our research and applied them to the field of crop farming. We have founded a company that uses these robots to efficiently weed farmland. As we continue to advance this technology, we are focused on refining the robot's design and functionality. While we understand the functional aspects of the centipede robot framework, our ongoing efforts are aimed at determining the optimal number of legs required for motion without relying on external sensing. Our goal is to strike a balance between cost effectiveness and retaining the benefits of the system. Currently, we have shown that 12 is the minimum number of legs for these robots to be that is effective, but we are still investigating the ideal number. And then the publisher says the research brief is a short take on the interesting academic work. The articles is republished from The Conversation, a nonprofit news site dedicated to sharing ideas from academic experts. And then it has more things other links you can go through. And I'll probably watch this video as in the future I'll be talking and doing reviews about robot stuff with Raspberry Pi and as in the more robotic type stuff on the simple scale and end. So anyway, that's for a future project. But for now, I'll stick with what I have. So, before I conclude the review, would like to first of all thank you for taking the time to watch this video, as you could be doing anything else, but you are watching this video. As this did provide value for you, what I'd like you to do is please click the like button on the video, or below the video that is. That way I'll be pushing the algorithm, more people will be able to view it and enjoy it. If you haven't already, please click the subscribe button. That way you'll have access to all the content on my video, as I do have a variety of content on my video. Also, if you haven't already, please click the bell button. That way you'll be notified of all my future videos. So what I'd like to do is thank you for watching this video. I do appreciate it. I'd like to wish you a great day wherever you are in the world.